So in Module 7, we are going to talk about conics, which are just specific types of graphs that you have in math. And before we do that, though, we're going to quickly review our distance and midpoint formulas. So to review, the distance formula, if you're given any 2 points, x1, y1, and x2, y2, located on the coordinate plane, the distance between those points is given by the formula d equals the square root of x1 minus x2 squared plus y1 minus y2 squared. I am going to show you briefly where that formula comes from. Now, you do not have to memorize this proof. You're not going to be asked to do it on an assignment or anything, but I do want to show you where we get this formula from. So I'm going to draw a little coordinate plane here. I'm going to have my x and y axes, and I'm going to put 2 points. So this is my point x1, y1, and then this is my point x2, y2. And I want to know the distance d between these 2 points. So the distance formula is actually derived from the Pythagorean theorem. So what I can do is I can construct a right triangle where the distance between those 2 points is my hypotenuse. Now we know from the Pythagorean theorem that the length of a right triangle, we know a squared plus b squared equals c squared. So that tells me that my hypotenuse, the square of the hypotenuse, is equal to the square of the sums of the other 2 sides. So I can write these other 2 sides in terms of my points x1 and x2. So a, which is the side that is along my x-axis, so it goes horizontally, its distance, it starts at x1 and it goes all the way until x2. So x1 minus x2 gives me that distance, and then I square it. Plus, same thing with my side b, I can do y1 minus y2 squared, and that's the distance, that's the length of my side b, and that equals the distance squared. Now, if I want to solve for my distance, I want to get rid of the squared. So we're going to take the square root of both sides. And that's how I get that the distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. So it's just the Pythagorean theorem. So let's go ahead and do an example. So I want to find the distance between the points -2, -3. So -2, -3. And 4, -8. So I'm going to go ahead, and it doesn't matter which point you choose to be x1, y1, and which point you choose to be x2, y2. I'm going to go ahead and choose the first point as x1, y1, and my second point as x2, y2. And I'm trying to find my distance d between those 2 points. So I'm going to have d equals the square root, and then I'm going to have x1, -2, minus y1, x2, 4, in parentheses squared, plus, and then y1, -3, minus y2, -8, in parentheses squared. And now I'm just going to simplify. So -2 minus 4 is going to give me -6 squared, plus, now in that second set of parentheses, I have -3 minus -8. And the minus and negative is going to turn this into addition, so I have -3 plus 8, which is going to give me 5 squared. So the -6 squared is 36, 5 squared is 25. And then I have 36 plus 25, and I get the square root of 61. So my exact distance is the square root of 61. But considering, we don't usually leave distances in terms of square roots, I can approximate that as a decimal, and it's about 7.8 0.81. We can also use the distance formula with triangles. So I'm going to have my triangle MNP, and I have 3 vertices. I have that M is at 1, 4. N is at -3, -2. And I have P is at 4, -3. And I want to know, is this triangle an isosceles triangle? So briefly, let's review an isosceles triangle. An isosceles triangle is a triangle where 2 sides are the same length. So what that means is I need to find the distance or the length of each side and figure out, are any of those the same? So I'm going to start with MN. So I'm going to let my M be my x1, y1. So I'm going to start with 1 minus -3 squared plus 4 minus -2 squared. So my 1 minus -3 is going to become 4 squared. And then 4 minus -2 is going to become 6 squared. I'm going to get 16 plus 36, which gives me the square root of 52. Now in this case, I am going to go ahead and leave this as in terms of square roots. It's just going to make it easier to compare to see if any of them are the same. Now let's go ahead and find the distance from M to P. I'm going to go ahead and keep M as my x1, y1. So we're going to start with 1 minus, and then we're going to have 4 in parentheses squared, plus 4 minus -3 squared. We're going to have -3 squared plus 7 squared, which is going to give us 9 plus 49, which is the square root of 58. So we have MP is the square root of 58. So far, not an isosceles triangle. That doesn't mean I can stop. I do have to check my third side, NP, because there is a chance that it is the same as one of the other 2. So in this case, I'm going to let N be my x1, y1. So we are going to have -3 minus 4 squared plus -2 minus -3 squared. So we're going to get -7 squared plus 1 squared, which is 49 plus 1, which is the square root of 50. So square root of 50, square root of 52, and square root of 58 are all different. So I can say that triangle MNP is not an isosceles triangle. Next, we are going to find the missing value from a point. So we know we have some point 54 and some other point 3k, and it's the distance between those 2 points is 4. So I want to find the value of k that makes that a true statement. So I'm going to let 54 be my x1, y1, and then the 3k be the x2, y2. So I plug it into my distance formula. I, in this case, know that the distance is 4. So I'm going to have 4 equals, and then 5 minus 3 squared plus 4 minus k squared. So we're going to have 4 equals, and then underneath the square root, I'm going to have 5 minus 3, which is 2 squared. I'm going to go ahead and leave the 4 minus k for right now. So that's going to be 4 minus k squared. And then 2 squared is 4. So we're going to have 4 plus 4 minus k squared. Right. Now I'm going to start solving for k. So the first thing I'm going to do is get rid of the square root. So the first thing I'm going to do is square both sides. So we're going to get 16 equals 4 plus 4 minus k squared. Now I want to get that 4 minus k squared by itself. So now I'm going to subtract 4 from both sides. So we're going to get 12 equals 4 minus k squared. Right? Now I have a squared I want to get rid of. So now I'm going to take the square root of both sides. Now typically what we've been working with, when I take the square root, I have to have a plus or minus. But since distance can't be negative, in this case I'm going to leave it as the square root of 12. And then it equals 4 minus k. Now I want to start getting k by itself, so I'm going to subtract 4. So we'll have the square root of 12 minus 4 equals negative k. And then my last step is going to be to divide through by negative 1. So we get that k equals negative square root 12 plus 4. So k is not a nice number, it is a decimal. And negative square root 12 plus 4 is about 0.54. So not a nice decimal or a nice number. Last thing we're going to talk about is our midpoint formula. So similar to the distance formula, you're going to have your points x1, y1, and x2, y2. And your midpoint is the point in the middle. So your midpoint of the 2 points is you're going to do x1 plus x2 all over 2. And then y1 plus y2 all over 2. You're basically finding the average of each, because if I want to find the middle, I find their average. So if I know 2 numbers, the number in the middle of them is the average of their 2 points. So midpoint formula, we have negative 2, negative 3, and 4, negative 8. So same as when we were finding the distance. So I'm going to let the first point be x1, y1. My second point be x2, y2. Then my midpoint, I'm going to do negative 2 plus 4 all over 2, comma, and then we're going to have negative 3 plus negative 8 all over 2. So it is important to remember here that a midpoint is a point. So you do need to have the parentheses and the comma. So negative 2 plus 4 is 2, so I have 2 over 2, comma, and then negative 3 plus negative 8 is negative 11 over 2. Now, because we're always going to be dividing by 2, if I get a decimal, it's going to be a nice decimal. So I will allow you to write decimals in this case. So 2 divided by 2 is 1, and negative 11 divided by 2 is 5.5. So my midpoint is at 1, comma, negative 5.5. And we typically do put the m in front to signify that we're talking about the midpoint. Let me know if you have any questions about distance or midpoint.